Welcome, everyone, to the Sysadmin Academy. So, you've probably sent a message to someone halfway across the world and watched it arrive in like a second. Ever stop and wonder how? How does it actually get there? Well, it's not magic, it's all about the physical journey your data takes. And today, we're diving deep into the superhighways of the internet, transmission media. This stuff is absolutely fundamental, and I'm gonna make sure you walk away from this with a rock-solid understanding. So, let's get right into it. How does that message really travel? Understanding this is what separates a casual computer user from a real networking pro. It's not just about clicks and screens, it's about the physical reality. We're going to pull back the curtain on the whole process, from the actual cables running under our feet to the invisible signals flying through the air. All right, so what are we even talking about? A transmission medium is just the physical path that our data travels on. That's the key word, physical. Think about it like this. If your data is a bunch of cars, the transmission medium is the actual road they're driving on. No road, no journey. It's literally that simple. Okay, so here's the roadmap for today. We're going to start with the physical pathways, what we call guided media. Then we'll look at how data travels through the air in unguided media. After that, we'll see how it all fits together on something called the electromagnetic spectrum. And finally, we'll break down what that data actually is, right down to the bits and bytes. Let's do this. First up, guided media. Now, the name here pretty much gives it away. We're talking about actual physical things. Cables, basically, that we put in place to guide a signal from point A to point B. Yeah, think of these as the tunnels and pipes of the digital world. The signal is contained, it's directed, it's protected. This gives us way more control, which usually means better performance and better security. We're going to look at two of the heavy hitters here, the old school coaxial cable and the incredible fiber optic cable. I bet you've seen this before, right? This is a coaxial cable. It's a true workhorse of networking. For years, this was the backbone for cable TV and a lot of the early internet setups. For local area networks, it was a huge step up, letting us send more data over longer distances than ever before. But the real genius of the coax cable is what's on the inside. Seriously, this layered design is just brilliant engineering. Every single layer has a job, and that job is to protect the signal that's traveling through the middle. Let's actually take a look at its anatomy. Okay, right at the center, you've got the inner conductor. That's the copper wire where the data itself is zipping along. That's wrapped in an insulator to keep the signal from leaking out. Then you get the really important part, the outer conductor. It's a metal shield that acts like a bodyguard, blocking any outside electrical noise, and the whole thing is wrapped in a tough plastic jacket. See? Every layer is crucial. All right, now let's jump to the technology that really powers our modern high-speed internet. Fiber optics. This is a total game changer. We're not pushing electricity through a wire anymore. Here we are sending data as pulses of light, literally at the speed of light, through a tiny strand of ultra-pure glass that's often thinner than a single human hair. It's amazing stuff. So you might be wondering, how do you keep the light from just, escaping the glass? Well, the answer is this incredible piece of physics called total internal reflection. The easiest way to think about it is like skipping a stone across a pond. If you get the angle just right, it just bounces perfectly off the surface. That's exactly what these light pulses do. They bounce perfectly off the inside walls of the glass fiber, which lets them travel for miles and miles with almost zero loss of signal. So what's the deal with fiber? Well, the advantages are just insane. We're talking mind-blowing speeds, huge amounts of data, and because it uses light instead of electricity, it's completely immune to electrical interference. Plus, it's super secure. But there's always a but, right? All that amazing performance comes with a price tag. It's more expensive, and you need highly skilled technicians to install it. It's a classic trade-off. You get what you pay for. Okay, but what about when you can't just run a cable everywhere? Think about your cell phone, your Wi-Fi, or connecting to a satellite way up in space. That brings us to the other side of the coin, unguided media. This is where our data travels freely through the air. And this is a really fundamental shift in thinking. With a cable, you worry about the physical medium itself. But with unguided media, it's all about the antenna that's sending the signal and the characteristics of the wave itself. The whole game changes from managing a wire to managing a signal that's out in the open. This table breaks it down perfectly. Think of microwaves like a laser pointer. They're highly directional, perfect for shooting a signal from one specific point to another, like a satellite dish. Then you have radio waves, which are more like a light bulb. They go out in all directions, which is why they're great for things like FM radio or TV. And finally, infrared. Just think of your TV remote. It's for short-range, line-of-sight communication. So we've talked about electrical signals in a wire, pulses of light in glass, and all these different waves flying through the air. You might think they're all totally separate things, but they're not. They're actually all part of the same big family. They all live on one master chart. And this is it, the electromagnetic spectrum. Honestly, this is one of the most important concepts for understanding any kind of communication. It's the aha moment. Look here, radio waves, microwaves, even the frequencies used for fiber optics, everything has its own dedicated lane on this spectrum. This is the one resource that all wireless communication has to share, and managing it is a huge deal. So we've figured out how the data travels. We've covered the roads and the airways. But what is the data? What are we actually sending? Well, when you strip everything else away, it all comes down to ones and zeros. Right, so we humans live in a base 10 or a decimal world. We have 10 fingers, so we count in tens. Computers, though, live in a much simpler world, binary or base 2. Everything is either on or off, a 1 or a 0. These other systems, octal and hexadecimal, are really just a convenient shorthand for us humans to read long strings of ones and zeros without going crazy. A single bit, a 1 or a 0, is the smallest possible piece of information, but when you start grouping them together, you unlock some serious power. And look at this pattern. Every single time you add just one more bit, you double the number of things you can represent. That exponential growth is what lets us represent everything from the letter A to an entire movie in just ones and zeros. And that brings us to this magic number, 256. With a group of just 8 bits, which we call a byte, you get 256 unique combinations. Why does that matter? Well, it's more than enough to represent every single letter, number, and symbol on your keyboard. The byte is the fundamental building block of almost all digital information. All right, that was a lot, I know. We've traveled from deep-sea cables all the way to outer space. So let's zoom back out and lock in the most important points from our journey today. I think the biggest takeaway is this. There is no single best way to send data. It's always a trade-off. Guided media, our cables, gives you amazing speed and security, but you're tied down. Unguided media, wireless, gives you incredible freedom and mobility, but you're more open to interference. A network professional's job is to look at a situation, weigh these pros and cons, and pick the right tool for that specific job. And that really is the big question, isn't it? As everything from our cars to our coffee makers goes wireless, how are we going to manage to keep everything connected, fast, and secure? That's the challenge that's going to define networking for years to come. I really appreciate you joining me for this deep dive today. Hey, if you found this explainer helpful and you're serious about your IT career, do me a favor and hit that subscribe button for Sysadmin Academy. We release new, in-depth videos like this every single week to help you crush your exams and build an amazing career. Thanks for watching, and I'll see you in the next one.